All right, next segment is about cloud computing. So the question is, so all these people are using these services like Google Search and YouTube and eBay and Amazon, all that stuff. What's the hardware they use? What do all these companies use to have millions of customers? Do they use supercomputers, these giant expensive computers, or mainframe computers, these kind of gold-plated things that almost never fail? So that's the question. Another question is, well, suppose I don't work for those companies. I've got this great idea, but I would love to be able to grow to millions of users, but do I have to build a warehouse computer and get some venture capitalists to invest $100 million in my idea, and we don't even know it's going to work? So am I going to be shut out, right? So what's the answer to this? It turns out, let's first list what you need, right? To do software as a service over the internet, you need to communicate to interact with that service. You need scalability. So what does that mean? So if you're doing like a photo sharing service and it's right around Halloween, there's suddenly all these photos are going to show up and you're going to need a lot more computing. Or if you're doing sales of like Amazon does around Christmas, there's going to be this huge demand, but the rest of the year not so much. So you have to be able to scale to be able to handle the load. Because if you can't scale to handle the load, then customers will get frustrated and go to your competitor. And it has to work. You've only got one copy of the software, you only got one copy of the hardware. If that one goes down, you're off the air, you're not making money and making customers mad. If, with shrink-wrap software, you can, if you have millions of copies, a few of them crash, so what, right? This is the only copy, it's got to work. So with the hardware that the people ended up doing was clusters. Clusters actually got started here at Berkeley as part of the network workstations project that Armando and I were involved in. And what a cluster is you put a bunch of computers together, like PCs or workstations, and you connect them with Ethernet switches. So just like what's in the buildings here on campus, but you dedicate them for the service you want to provide. Now what happened was that this proved to be much more scalable, that a network is fundamentally more scalable than other choices out there. It was a lot cheaper. People, Urs Hosel and Luis Barroso wrote a book about warehouse scale computers, and they think it's about a factor of 20 cheaper. So for the same amount of computation or disk storage or memory, it costs 20 times as much to buy the gold-plated stuff from a mainframe like IBM versus PCs. And the way they get dependability in clusters is just to have a lot of redundant copies. So if it's 20 times cheaper, you can afford to have 3 replicas of everything. It's still, 1/7 the cost of the gold-plated version. So the parts aren't very dependable, but you have triplicate them, and so collectively the software makes that dependable. And it turns out if you have thousands of computers, all pretty much the same, all running the same software, they're not that hard to manage. So that a few operators can handle thousands of servers, and then as we talked earlier, virtual machines can really help make this work, so that's another thing that can simplify the tasks. So warehouse scale computers soon grew. The first ones had maybe 1,000 servers, but as customers increased over time, they have now 100,000 servers as the demand increased. What they discovered is when you build a warehouse of computers and you order 100,000 computers at a time, you get huge economies of scale. If you were to go to Dell or HP and say, I want to buy 100,000 computers, they're going to give you a really good deal. If you're going to build a warehouse rather than just for 1,000 computers, but 100,000, that's a much more efficient way to build it. And if you get network bandwidth by the gigabits as opposed to by the megabits, that's much cheaper that way. So by factors of 3 or 8. So by factors of 3 or 8 per computer, it was cheaper to do the warehouse scale computing. Also what happens is traditional data centers are underutilized. So if there was 100 data centers, each with 1,000 computers, maybe they're used 10 or 20% of the time, but if you consolidate them together, they get more utilization out of them. So what ended up happening is, particularly starting with Amazon, they realized they could earn money to offer a pay-as-you-go service because their costs were so much less that they could sell it to less than the customer cost, but they could still make a profit. And so the characteristic of this, what's called the utility computing or public cloud computing, is it offers computation and storage communication at pennies per hour. And remarkably, there's no cost to scaling. Usually if you want a 1,000 times faster computer, you pay a lot more than 1,000 times more for that privilege. Here, 1,000 computers for 1 hour is the same price as one computer for 1,000 hours. Their job at companies that are providing this is to make you think you can have as many computers as you want. And their job is to fulfill that pledge, which is very attractive. And Amazon Web Services, Google App Engine, and Microsoft Azure were the leading ones to do this. Over the years now, Amazon's been doing this about 7 years. I think their model has won. So now Google App Engine and Microsoft Azure are pretty much imitating what Amazon Web Services did. So this slide I just took together, which is now there are 17 different types of instances that you can get there. The original one, the small one, which 7 years ago was 10 cents an hour, is now 6 cents an hour, and that's kind of the building block. You see things that cost 75 times as much down here, and you can see things with 100 times as much memory and 100 times as much compute units, all kinds of flavors, different ones. So you can, whatever your task is, you pick the one and you pay the price. So when Amazon came out and they announced they're doing things for 10 cents an hour, and said, oh, they got to be losing money at that. Well, that was 7 years ago with Moore's Law, right? So 7 years later, they went from 10 cents an hour to 6 cents an hour. So only a 40% drop despite 7 years of Moore's Law, which could be a factor of 100 cheaper. So they are perceived as making a lot of money doing this. I went to a conference last year from Amazon, their first public conference, and they said a remarkable statement. They said, every day they roll out as many servers as it took to run Amazon.com in 2003 when it was a $5 billion a year, 6,000 employee company. So in the beginning when this started, the person who made the argument for Amazon to get into this is we have all these computers, we only need them near Christmas, let's rent them out the other 11 months per year. Well then, it's an interesting argument, what happens at Christmas, right? Well, they got started in it and suddenly it became so popular that the roles were reversed. Now, Amazon.com, where you go buy books, they don't have any computers. They're just a client of Amazon Web Services, and they're a relatively small client of Amazon Web Services. And Netflix and many others are doing that. So, and they're rolling, I don't know, 5,000 servers a day. I don't know how many servers they're putting out. Another thing they did to kind of show off was that they could build a supercomputer out of these rented services. So they put 500 of these larger ones together, and they were able to do 240 teraflops, which at the time put them in the top 100 of the fastest 500 supercomputers in the world, and that cost about $1,300 an hour. So that you can rent a supercomputer with your credit card. Who could take advantage of this? Well, when Zynga did Farmville, they could have built their own data center, go to venture capitalists, and say, well, we need a bunch of servers to do this. The biggest online game before that had been 5 million users, so we need enough servers for 5 million. That's the biggest one, so we'll start small. Fortunately for them, they went to Amazon Web Services, and so every time the number of customers increased, they just increased their credit card limit and got more servers. So in the four days, they went up to 1 million. You know, from 0 to 1 million in 4 days. In 2 months, 10 million. 9 months, 75 million. And if it hadn't been for Amazon Web Services, they couldn't have done that. So they were able to take in as much income as they could get computers without having to do that. So think about that for a minute. You've all heard of the Jeopardy champion Watson. So the amount of hardware is about 90 of these servers. Let's say we picked one that's like $200 an hour. So what's $200 an hour? That's like what, you know, when these people we talked about earlier, an attorney or an accountant gets paid. A good attorney or accountant gets paid $200 an hour. Think about in your careers as machine learning starts to work and AI starts to work, kind of for what task could AI be as good as a highly trained person at $200 an hour? That's today's prices, right? It's going to go down. So what is this going to mean for society, right? What is this going to mean as computers get smarter, can do more things, and you know, what jobs are out there? I have this sense that we are this, you know, tremendously efficient job-killing industry. that I think the reason attorneys used to be a pretty cool job is dropping. I think it's got to do with computer technology. They're good at discovering things that they used to use law clerks to do. So, yeah. So this is a really good job. This is a good one to pick because I'm sure there's going to be demand for this. I just hope that we're going to start getting into the job generation side of things. Okay.